Welcome to question 2. For the workbook, the diagram shows point A at -3,5 and point B at 8,1. What is the distance between the points? Enter your answer as a number rounded to one decimal place, if necessary, like this, 42.5. Okay, so they want to know if I were to draw a straight line from A to B, what is that length? Wants to know how long that is. So one of the beautiful things of this coordinate system is that you can create right triangles by having a horizontal line intersect or connect at a corner with a vertical line, because horizontal and vertical lines create 90 degrees. Why would we want a 90-degree angle? Is we would want to create a right triangle. The reason we want to create a right triangle is because to find side lengths, we can use the Pythagorean theorem. And again, the Pythagorean theorem is a squared plus b squared equals c squared. So we are going to first want to draw our own right triangle. So the easiest way to do that for me is from starting at point A, going horizontally straight over above point B, and then going vertically straight down to point B. Again, notice this creates that 90 degrees, which is what we want. And so now we have our right triangle. We can find side lengths by either using the coordinates like they showed you above through the lesson, or you can find the distances by counting. I say use whatever tools are given to you and whichever tools are fastest for you and most efficient. That's one of the skills to be a good learner or a good mathematician, is learning the tools and the skills that they give you and applying them to whichever ones make it the most efficient for you. So to me, it's most efficient to count since it's already on a grid line. So from point A to point B horizontally, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units long. Vertically, it is 1, 2, 3, 4 units long. And now you might be saying, wait a second, but you went down, so there should be a negative sign right there. You are correct in terms of direction. That negative sign is representing that I went down. When we're talking about distance, distance can cannot be a negative distance, so that's why I'm keeping it at a 4. Now, if we notice, it is kind of convenient that what we're looking for is our c squared, or our hypotenuse, and so how I know that is because the hypotenuse is always going to be across from the 90-degree angle. So I know that this is c squared. So it's across from the 90-degree angle. This means that this side length is c. I can label the other ones as a or b, so that when we come over here and we use substitution, so we have our Pythagorean theorem. We represented this a side length is 11, b is 4, and c is c squared. So now how do we solve for c? That is our goal. So first I would notice that c squared is by itself. There's no numbers there, so I'm going to add the first thing that I'm going to think is, since there's no numbers by c squared, how do I undo a square? Because right here it's c squared, not c. The opposite in operation, or the inverse operation, is a square root. So we would take everything we had and we would add a square root to both sides. So we would have square root of 11 squared plus 4 squared, and that's going to equal our square root of c squared, since we would square root both sides. Now the square root of c squared, the whole reason why we would do that is so that it would come out to be c. And I'm just going to leave the square root of 11 squared plus 4 squared underneath that square root until I jump over to a calculator to simplify. So now you might be saying, that's not the distance formula they taught me. It had the coordinates. Can this still be used? And I'm saying yes, and the reason why is because when you're using the coordinates, the x coordinates are representing horizontal movement. So I counted the horizontal distance to be 11. That is just as valid as if you took -3 and you subtracted 8 from it. -3 minus 8 is -11. Since it's being squared, -11 squared and 11 squared come out to be the same number. So yes, it's okay if you use your tools and it doesn't look exactly like the formula, because you're not using I'm not using the formula steps. I'm just using the tools that they gave me. So in the calculator, I would type in square root 11 squared plus 4 squared, and I would close these parentheses to make sure that that whole thing is underneath the square root. Click enter, and it gives us 11.7 is equal to c. So when you come back over here, what is the distance between that point? Again, remember that c is representing that distance. It was what we were looking for, and it is 11.7. So I guess another way to remember the distance formula could be just as I would just write it in horizontal distance, whether it's counted or whether it's found algebraically, and the vertical distance. So again, we just showed that using the Pythagorean theorem, that's how it works. That's the reason why we end up with this type of formula. I'm just going to keep it in word form because it's easier for me to understand what those letters and symbols are representing versus just writing it out in math. So, okay, distance formula is the square root of the horizontal distance squared plus the vertical distance squared. I can do that. I hope that helps.